Year 12, this is the review video for exercise 12I, which is on stationary points. Right. So I asked you to have a go at these questions 3A, C, E, and G. Now I've run out of space here because these questions take up a lot of room, basically. Okay, there's a lot of like little kind of niggly steps to them. So it's important that you know what you've worked out when you've worked it out. So as I say, I've said a couple of times, make sure you try and sort of set these out as much as possible, as easy to follow as possible as you can. So for 3A, you're being asked to find the point where the gradient is 0, which effectively means find a stationary point, and then decide whether it's a minimum, a maximum, or a point of inflection. So for question 3A, dy by dx times by the power decreased to the power by 1 gives you 8x plus 6. So figure out where the gradient is 0, set that equal to 0. That gives you a coordinate where x is minus 3/4. Okay, which means that you then sub that back into y, because you want the coordinates of it, you need to sub it back to y, which gives you minus 3/4 over minus 9/4. And then what you do is to figure out whether it's a minimum or a maximum. So that coordinate there, that is the coordinate of the stationary point. To figure out whether it's a minimum or a maximum, figure out your second order derivative. So we differentiate that, we'll get 8, which is always going to be positive no matter what value of x you put into it, because there's no x involved, which means that because that's positive, it is a minimum. Okay, and you must write that line down. Okay, right, part C. You're starting up there. So when you differentiate this, you're going to get 3x squared minus 2x minus 1. Set that equal to 0. It gives you 2 points. The point when x is 1, the point when x is minus 3. Sub both of those back into your y up there. So sub them both into this. That gives you 0. So it gives you the coordinate 1, 0. And this one gives you the coordinate minus a third, 32 over 27. To decide whether each of these is a minimum, a maximum, or a point of inflection, we figure out our second order derivative for this thing, which is going to be 6x minus 2, and then sub in the x value for both of these. When you sub in 1, you will get the second derivative equaling 4, because that's positive, it means it's a minimum. And when you sub in minus a third, you will end up with minus 4, which is negative, which means it's a maximum. Okay. Right, for part E, you have to rewrite the equation as y equals x plus x to the minus 1. Differentiating it then gives you 1 minus x to the minus 2. Setting that equal to 0 and solving ends up giving you that x is 1 or minus 1. Subbing 1 or minus 1 back into your original equation will give you when x is 1, y is 2, and when x is minus 1, y is minus 2. So it gives you those two coordinates. Figure out your second order derivative. So differentiate this thing again, will give you 2x to the minus 3. Remember what I was talking about in the review exercise for 12H, that be careful multiplying powers that are negative a couple. You forgot that last time, so that's why that has gone back to positive 2, because you've got minus x times minus 2, which will be positive 2, x to the minus 3, and then sub in x equals 1 and x equals minus 1. When you sub in x equals 1, you get a positive answer, which means it's a minimum. And when you sub in x equals minus 1, you get a negative answer, which means it's a maximum. Okay? Right, G, I've had to go on to another bit of paper. So G gave you this curve, y equals x minus 3x to the half. It was written as 3 root x, but you have to write it like that to be able to differentiate it. Differentiating it gave you that. Setting it equal to 0 gives you this, and you end up then with x equaling 9/4. Subbing that back into y gives you that y is minus 9/4. So that's your coordinate for your turning point, 9/4 minus 9/4. Figuring out your second order derivative gives you 3/4 x to the minus 3/2. And subbing in 9/4 gives you positive 2/9, which means it's a minimum. Okay. Right, question 5. Now question 5 says, by considering the gradients on either side of the stationary point on the curve, show that the stationary point is a point of inflection. So what you have to do is you differentiate it to get this, set it equal to 0, and then you should only get there that there is only one root of this equation, which is x equals 1. Subbing 1 back into this at the top gives you that y equals 1. So there's your turning point, 1, 1. Now, because it tells you to consider the points either side of the turning point, it gives you the values to use there. Effectively, it means take the point to the left and right of x equals 1. So we're going to use x equals 0, and we're going to use x equals 2, because they're either side of 1. When we use x equals 1, subbing it into this gives you a gradient of 3, which is positive. When we use x equals 2, it gives you a gradient of 3 again. So because there's been no change of sign, it means that it must have been a point of inflection. It means that it must have had a gradient sort of coming up. Gradients of 3 there, bottomed out to a point of inflection. There's my coordinate for my stationary point. And then it's gone back to having a gradient of 3 again, like that. Okay? So, and again, you must write all these kind of conclusion bits down. Seeing that quite a lot from people where I'm having to say, look, you've done all this right. Already as a boss at differentiating stuff, you can do that. You can solve the equations. Just make sure that when you're being asked to prove something, write down at the end of what you've proved. Make sure you finish these questions off, because what I think where we are with a lot of you at the minute is that you are getting 60% of the work absolutely spot on, which is fantastic. Do you know what I mean? You're effectively teaching yourselves this, so well done. But just make sure, try and kind of mop up these little extra marks at the end, because it's those that will make the difference between like a C or a B or an A or an A star. Right, and then question 6, which I've got down the bottom here. Where is my question 6? Okay, so this said, find the maximum value and hence the range of values for the function f of x is 27 minus 2x to the 4. Now, finding a maximum value basically means find a turning point of it, or the stationary point. So when we differentiate this, we get minus 8x cubed. Now we have a problem with that, because when we set it equal to 0, it means that x must be 0. But technically, something with a cube should really mean that there are 3 solutions to this. And it means that we have a problem later on. So anyway, we get that x is 0 at the stationary point, which means if we sub it back into that, we're going to get 27 minus 2 times 0, so we're just going to get 27. So our stationary point is 0, 27. The problem is we've now got to basically prove that that is the maximum, that's a maximum. Because if we sub in 0 to our second order derivative, we get 0 again, which would suggest that it's a point of inflection, but it isn't. So when we sub that in, it gives us that the second order derivative is 0. It just basically means that there is no change in the gradient at that point, which isn't true. Okay, so what we have to do there, and the reason for that is because of what I was chatting about there, because this is like, because it's 0, it throws up a problem. So whenever you get the gradient is 0, or the change in the gradient is 0, you then need to consider points either side of it to prove whether it's a maximum or a minimum or a point of inflection. So if we consider, remember we had our x value there is 0, we're going to consider minus 1 and positive 1 because they're either side of 0. When we have minus 1, sub that into your gradient function, that will give a positive 8. Okay. When we consider positive 1, sub it into the gradient function, it will give us negative 8. So that means that this thing, the gradient has gone from being positive, so facing that way, to negative, facing this way. So it's gone like that. So therefore, that proves gone from positive to negative, therefore it's a maximum. And therefore, all we need to do is figure out what the value of the function is when x is 0, which will be 27, take away 0, which is just 27. Okay, which means that all the values of x, no matter what value of x you put into that, the biggest thing you can ever get is 27. So that's the range. The f of x is less than or equal to 27. Okay. So the last one, question 7, that gives you this function and says find the coordinates of the stationary point and determine the nature of each, and then sketch the graph. So differentiate it, set it equal to 0. Now it does say in there to use the factor theorem, so you can either use the factor theorem, or to be honest with you, I know I said to do that, you can just put it into your calculator. You can put a cubic into your calculator. So if you go to the equation bit, polynomial, but this time you want a cubic, so just put in 3, and it allows you then to put in something with an x cubed, something with an x squared, something with an x, and something with a constant. So plug all them in and it gives you -3, 1 and -1/4. Okay, now putting all those three things back into your original function to get y will give you those three stationary points there. That one, and that one. Okay, then to determine whether they're all maximums or minimums, figure out your second order derivative. So differentiate this thing again. 12x squared plus 18x minus 10, and then sub in for this coordinate, sub in -3. That gives us positive 44. So this one is a minimum. Subbing in 1 for this coordinate gives us 20, which is positive. So that one's a minimum as well. And then subbing in -1/4 gives you -55/4, which is negative, which means that one is a maximum. Okay, so there's the three stationary points, and there's what type of stationary point they are. So what we now have to do is turn this into a graph. Now the only three things when it's saying and hence sketch the graph, you've got those three coordinates and you know whether they're minimums or maximums. So what I've done here is just marked on roughly where those points are and then fitted the graph to there. Remember that these were the only minimum and maximum points, which means that if this is a minimum point, that this graph must be coming down towards it like that. That's your maximum point there, which is this one, which means it's going to top out there and start to come down again until it hits this final minimum point like that and then goes back up like that. Okay, so these three things there, which have allowed me to sketch the graph, are those three stationary points that we decided, and then you're using whether they're minimums or maximums to decide how to shape your graph around that. Okay.